Hello friends, hi. Now today we'll study dose versus response curve, or it is nothing but the toxicology test that is carried out. Now how it is carried out? So there is a principle based on that. So what it says that biological organisms responds differently to the same dose of a toxicant, and this difference in response are generally as a result of the change in the age, then sex, then weight, diet, and then general health, and various other factors. So this is the basic for dose versus response curve. Now in this stage, what they will do, what the work is there. So we will give a known concentration of a toxicant to the number of individual, and we have to record the different responses of each and every individuals. So we will get, so there will be a very different uh, responses will be there. Now there is a one example we have seen. We will see in this slide that if we consider a toxicant to be a vapor which will irritate the eyes, so if we give that vapors, if we expose that vapors to the number of individual present in the room, so what will happen? So there will be a different responses of each and every individuals of to that vapor. Some will have a more irritation in the eyes, some will have a very little irritations in the eyes. So they will, some will have no response to that vapors. So these are different responses will be there in the room if we give a small vapors. So this is the basic for studying dose versus response. Now what we will do, in this we will take a test run. So what they will do, they will take a small concentration of toxicant, and it will be given to the large number of individuals. So each individual is exposed to the same dose, and their response will be recorded. So this is nothing but a probability distribution type of equations, where so generally they analytically we don't know what are the responses, so there will be a various probabilities will be there. Now for studying that in detail, we have to consider a equation or a graph, that is a normal distribution equation or Gaussian distribution equation. What it says that, there is an equation for a normal distribution curve. So this is the equation where we can the our test will be a same of that of Gaussian distribution curve. So what is this equation we have to consider, where fx is the probability of individual experiencing a specific responses. Now here x will be a response, then uh, the sigma will be the standard deviation, and mu will be the mean of the equation. So we will consider this type of equation. Now why we are considering, because this is nothing but a probability theory. Now for probability theory, very generally Gaussian or normal distribution equations are considered. So we will consider this equation. Now from that equation we will get this type of curve. So this is the mean. Now this will be the percentage of uh, percentage or a fraction of individual affected. Here the responses will be plotted. So this is from after the considering the test run. So we will get this type of curve always. It will have some mean over there. Now so this will be the curve after the test run. Now from the curve itself we can see some of them will have a low response, some of them will have a high response, and maximum of the person will have a average response. So this is the area under this curve will have a maximum number of responses. So it is a probability theory. So that's why we are considering the Gaussian or a normal distribution curve. So that is a this is how the data is analyzed, and it is recorded for number of doses. Now we can consider, so this is the simple. Now, what Gaussian equation or distribution, normal distribution equation says that standard deviation and the mean, they characterize the shape and the location of a normal distribution curve. They are computed from the equations. These are their how they are calculated. Now here, what is x? X is nothing but a response, and the fx are nothing but a probability of number of individuals affected. So this is how mu is calculated. Now that is the mean is calculated. Then this is how the standard deviation, or it is called as a variance, is calculated from this equation. So this is the Gaussian theory law, from where we can get number of we can get the values of mu and the standard deviation or a variance. Now from here, or here in this equation, n is nothing but the data points, and the quantity is sigma square is nothing but the variance. Now here, mean determines the location of the curve with respect to x and the standard deviation. So this is how the curves has been plotted. Now we can see various stuff. What is the application? What is the uses of that standard deviation and the mean? Now we can see, as the value of standard deviation is 0.25, you can see the curve is simply like this. Now if we increase the value of this standard deviation, what will happen? Again we will get this type of curve. So this type of curve is for 0.5. Now for the standard deviation value is equal to 1, so we will get this type of curve. So this is the application of the standard deviation. Now if you see that as the standard deviation decreases, so the distribution curve becomes more pronounced to the mean value. Now we can see if it is 0.25, so the mean value will be more. Again, if it is 0.5, mean value will be less. Again, it will be 1, so mean value will be again very less. So this is how the plots are plotted and the data is analyzed.